This is 5th grade, lesson 6-3, page 201. We are talking about converting metric units. Okay, so metric units means we're talking about the metric system. The entire world uses the metric system. In fact, there's only, from a source I'm looking at right now, Statista.com or Statista charts, there's only 3 countries that do not use the metric system in everyday life. That's Myanmar, Liberia, and the United States of America. You'll notice, well, you probably know, in the United States we use the imperial system, which is inches and feet and miles. And we learn the imperial system. We know a lot of the basics through memorization. We know that 1 foot is 12 inches. That's cool. But everything's kind of scrambled up in the imperial system. There's no set pattern to convert one thing to another. It's straight memorization. The metric system, which we're talking about today, which every other country in the world uses, and even scientists, that tends to be what we use in science class when we can. The reason the metric system is so popular is because everything in the metric system works off of a power of 10. Okay, every single pattern is understandable and convertible through one easy method. So today we are going to convert metric units using powers of 10. So let's dive right in. I'll show you what we're talking about. I think it was lesson 6-1 when we were talking about multiplying and dividing by powers of 10. Let me double check that. Yep. And we talked about a few rules to keep in mind. That when you're multiplying by a power of 10, we're moving that decimal point to the right. And when we are dividing by decimals, or dividing by anything by a power of 10, we move the decimal to the left. So divide goes left, multiply goes right. And not only that, but the exponent tells us how many places it's moving. So if we're multiplying something by 10 to the 4th power, that means our decimal was going to move 4 places today, or excuse me, in this instance. So let's take that to our chart here. We're going to work backward a little bit. Number 1 says there are 100 centimeters in a meter. Use this information to write a rule in the function machine. Then complete the what's my rule table on the right. So if you look at this table, and we're thinking only about powers of 10, okay, what would you have to do to this number 1, the n, for it to result in an answer of 100? Now, some of you might say, oh, well, 1 plus 99 equals 100. And that's true, but we have to remember what I just said about the metric system. The metric system works in powers of 10, which means we need to figure out, it's not going to be an addition problem. We're going to talk about what can be multiplied. What can we do to this 1 using multiplication, or in some cases division, if that would make sense, for it to equal 100. Okay, and we know in this case we have a decimal point here. It's imaginary, but if we were to put 1 down, he would be right after the 1. And if it helps, think about how many places would we have to move him to result in 100. And we have to move him 1 place value, 2 place values. So remember what we said from 6-1. Every time you move a decimal, a place value, that's going to be at least 1 exponent. And how many places do we move it? 1, 2. So that means our exponent is going to be 2. We can go 10 to the 2nd. Then the question is, what direction did this decimal move to add these new zeros? Did it move to the left or the right? And we know here it moved to the right. So we also know, if we look at our notes, that if the decimal is moving right, that means it is a multiplication problem. So here, our rule becomes times 10 to the second. And do you know what 10 to the second power means? It means 10 times 10. And what is 10 times 10? 10 times 10 is 100. So ask yourselves, if we multiplied, we can check our work, if we multiplied 1 times 100, is this what we get as our answer? Yeah, 1 times 100 is 100. Okay, so I know I'm throwing a lot at you, but let's apply this rule to number 2, or our second entry. We know that, again, the imaginary decimal, 2 is the same as 2.0, right? If that helps you remember where the decimal would be. And our rule is times 10 to the second. So again, that's just going to mean take that decimal, move them twice. What goes in those empty slots? Zeros. So that means if 2 goes in, 200 comes out. And many of you may be able to recognize the pattern we're creating here. So if we have 100 for 1, 200 for 2, yeah, you can probably just, 300, 400, 500. Okay, so the key here is going to be recognizing how many places our decimal is moving from our example, from the in to the out. Not only how many places, but what direction is that decimal point moving. And that's going to tell us whether the rule is involving multiplying or dividing. So, in fact, if you wanted, I'm going to add another possibility. I know we put 10 to the second power, and that's my preferred answers because we're talking about powers. But if you simply recognize that times 100, what we're doing is multiplying it by 100, that's cool too. I just want you to know that these are the same thing. 100 in this case is the same as 10 to the second power, which is basically 10 times 10.